Okay, everybody, this is just kind of a review of what I believe that we have covered this semester. And so I want you to use this video as kind of like a study guide. I'm leaving all the equipment. I'm going to point out what we've covered this semester, because we've done an awful lot of things so far this semester. When you first started here back in August, we came into the back room and we started to talk about oxygen tanks. Okay? We talked about H cylinders, we talked about E cylinders, we talked about ASSS connections, we talked about pin index safety systems, we talked about how to hook up and crack the tank, we talked about our manifold and regulators and how when we open up our tanks, we open up slowly, we don't want to cause any damage, we also want to make sure that we don't have anything called adiabatic compression, where these little metal flakes can flake off inside the tank, come out of here, get up to this part, the stem, the neck, and come out really, really fast and hit the regulator, and it can cause increase in heat, and with heat and pure oxygen, it's not a real good combination. And any kind of static or spark can cause some type of explosion. But you need to make sure that you've reviewed your tanks, your manifold system, the piping system, the blueprints, where they're held, because we have zone valves throughout the hospital. We talked about H cylinders, and as you notice here, how the tanks are stored in a rack with chains. Tanks not used with caps. Tanks not E cylinders, they're in carts. Okay, very, very important that you review tank safety. Then we went from there, we come over to this side. We talked about safety, and that's why I'm looking at the hand cleaner, okay? The alcohol-based hand rub. Remember, put it on your hands, wash it all around, and let it air dry. Washing your hands, you sing happy birthday. I have gloves. Gloves are not always mandatory, but they're not ever forbidden. Okay, you can use that. We also talked about wiping down our equipment, wiping down what we have, keeping an aseptic technique. We also talked about how we should be safe in the classroom, protecting one another, making sure we're looking at each other, making sure if we're going to cough, we cough into our sleeves, okay, and really good hand washing. We need to all be part of being careful of each other and for each other in the lab. Then we talked about different types of oxygen devices. Here we have air flow meter, oxygen flow meter. We had nipple adapters or Christmas trees. We had our double quick connect, which allows us to use this, the Ohio Diamond, to quickly connect our devices together. We have flow restrictors, in which we talked about that. We had board-on gauges, which regulate pressure and also allow you to adjust flow. But our board-on gauge, the way it worked was a little different because it actually measures pressure both ways. But on the flow side, instead of giving you a pressure measurement, it gives you an equivalent flow reading. Then we also had a regulator that had the pressure regulator and also a Thorpe tube. This one would be used on an H cylinder. This has to be used in a vertical position. We talked about pressure compensated and uncompensated and what that means. So you need to make sure that you review those parts. This part over here, the reason for the time was also we looked at military time, regular time, but here the barometric pressure, what 1 atmospheric pressure equals. 760 millimeters of mercury, 760 millimeters of mercury, 29.9 inches of mercury, it equals 1,034 centimeters of water pressure, 14.7 pounds per square inch, or 33 feet of seawater. And we needed to know about those conversions. Those conversions will help you because you're already doing that with Tracy with cuff pressures. But that was over here. Then we also had different experiments that we looked at through the semester. You know, just looking at this, if I get a lot of volume inside this syringe, my pressure is 0. So volume's high, pressure's low, but as the volume goes down, my pressure goes up. That means there's an inverse relationship between pressure and volume. That was Boyle's law. We talked about Dalton's law. We talked about Bernoulli's principle. We talked about air entrainment, and I showed you the example with the ping pong ball. And we also did with the large volume aerosol entrainment nebulizer and the Venturi mask, showing you how the mist gets entrained in. We had Zach showing us how to use this and demonstrating how the aerosol is actually, that's a visible molecular water that's put into a dry gas or into a medical gas. And Zach was able to demonstrate for us the flow going against the surface of the water, and we saw it starting to come out, and it actually sounded exactly, what was that?
Exactly like the large volume.
And that's exactly what's happening. That's how that works. We talked about, remember the soda can experiment? When I blew the straw, the forward velocity, as the gas was going faster, as it went by, it caused the soda cans to collapse in, decreasing the lateral wall pressure. Showed you how to use pulse oximeter, turning it on, and what it actually does by doing checking the patient's saturation of the actual hemoglobin, normal being 95 to 100%. Then we looked at oxygen devices, our nasal cannula, our simple mask, our non-rebreather, partial rebreather, and the difference. We went from a simple mask and we made ourselves a non-rebreather by adding or taking away parts, valves and reservoir bags. Here is our air entrainment mask. There are several different types. There's 3 different types. There's the one you have plus these 2. They're used in our hospitals in our area. You need to be familiar with them. They all are high flow devices that must meet or exceed the patient's inspiratory flow demand. Then we had the O2 analyzer. And this is using the galvanic fuel cell Clark electrode. And as soon as it's exposed to room air, it starts to work. We talked about that. The calibration process is the 2-point calibration, room air and 100%. And that's right on the back. You need to make sure you review that, because it's important to know if you're going to analyze your gas that you know that you're getting an accurate measurement. If you're on a ventilator, it's normally anywhere between plus or minus 5%. Over here, we started talking about large volume aerosol nebulizers. This was your double high flow when we talked about high, meeting or needing the patient's inspiratory flow demand. And we teed it together. We had large bore corrugated tubing, and then we added a water trap. And the reason we added the water trap is we didn't want the condensation to build up, which is contaminated waste, in the circuit and block flow. When it blocks flow, it actually causes the FiO2 that's actually being delivered to the patient to go up, but it also causes the total flow of the device that's going to the patient to go down. And it could cause the patient to aspirate and cause a major infection. It's a hazard for everybody. And that condensation, you must always consider contaminated waste. This is a special adapter that the hospitals will use for high flow. Single bottle, so take a look at that. And then when we set up our devices, we had our face tent, our aerosol mask, our trach collar, and our T-bar with the reservoir. I've actually set it up in line as a single bottle, and I want to show you that I have the O2 analyzer set in properly. Should always be closest to the patient, but if I was leaving it in, I'd want it pointing down and not upward, because that water would get on the membrane and cause the membrane to be covered, and I couldn't read the oxygen correctly. Then we looked at the non-rebreathing circuit. The big part to this really was the blender. The blender takes 2 different gases, oxygen and air, 50 psi, and it blends the 2 gases together using a proportional valve. That proportional valve allows us to get whatever concentration we want. Now, Zach, if I turn this to 40%, what is my air to oxygen ratio? Anybody? Remember 3 to 1. Okay? And what do I mean by that proportional? For every 1 part pure oxygen, I'm going to add 3 parts air to get 40%. If I go to 60%, does anybody remember what the air to oxygen ratio was for 60? 1 to 1. So for every 1 part oxygen, I add 1 part air, I get 60%. If I go down to 30%, or say 35, 35%. Does anybody remember what that was? 35%. 5 to 1. For every 1 part pure oxygen, I have to add 5 parts air. If I go down to 24%, it's 25 to 1. 1 part pure oxygen, 100%, and 25 equal parts pure air. How does that mix? Using a proportional valve, and that's inside here, and that's the blender. I use a non-rebreathing mask when I'm using a non-rebreathing circuit. I also use a non-rebreathing mask when I'm using heliox, because I don't want any other gases going to the patient. And when we did heliox, remember we had to convert the flow, because the flow meters are calibrated for oxygen, and we convert that using for an 80-20, 1.8, and a 70-30, 1.6. I've had the mannequin here because you can hook up whatever your masks are to the mannequin appropriately, whatever your oxygen device appropriately. Then we started talking about the different types of humidity. This here was your cascade. The water would come in here, increase the surface area, increase the opportunity for evaporation or for more water to get into the gas. If I add the top part, these 2 metal bars, they get submerged into the water, and that will cause the water and the surface inside here to warm up. If I increase the gas temperature, I increase the gas's capability of holding more what? More water content. So that was one way. Then we also talked about this device here, and this was our conchotherm. This was using the wick, okay, an absorbent material inside. And we talked about with that absorbent material inside, what it does is increase the surface area and increase the temperature as the gas goes over this wicking material inside. Both temperature and surface area go into play, and it helps increase the water content. What's really good about this device is that it had a servo-controlled, a temperature probe, which allows us to set a temperature, and we have to be very careful because it also has an alarm that we are actually delivering. We set that temperature probe up to be closest to the patient, okay? Because if we want 34 degrees or 35 degrees Celsius, we want it to actually be here, because the distance between the temperature at the wick and here, it has to go through the whole environment. And the environment might be cooler, and you'll have condensation build up, and we have to think of ways that we can reduce that, because condensation can cause a lot of problems. I'm not going to review it. We could use a water trap, the cup or the bag, or we could actually use a heated wire circuit, which would decrease the amount of condensation inside the circuit, so that doesn't cause a problem. The other device that we used, we were talking about this semester, was the small volume nebulizer. Okay, and that's what you're working on now, and the peak flow meter. And how to use a peak flow meter, how to give a small volume nebulizer. Tracy's going over the different medications, and then the other thing we did was the treatment bag, and you give it with a pipe, but you can give it with the mask, but it's less effective. I've chosen a small pediatric mask because I want you to know that you can give them with different size masks, and I want you to be aware of that. We also have a large heart neb that we have that when we give continuous nebulizer treatments, and a mini heart. This allows us to give multiple treatments instead of filling up one of these small volume nebs one at a time. I can give 12 treatments in a row in this. Put all the medicine in here and watch it. This here is an air compressor, because we can give our breathing treatments with oxygen or air, or an air compressor. I want you to make sure you practice using this too. You'll see that all three, they all work. This is the slowest. Air and oxygen work just as good, but remember that oxygen has bronchodilatory properties itself. Then I showed you the croup tent. and we had that aerosol that kind of misted out of here, that really dense mist. That's so similar to an ultrasonic nebulizer because the water molecule, it's just so thick. And then tomorrow, we're going to be looking at the high flow nasal cannula. And this is very, very simple. There is really nothing more to this. Okay, you turn it on and you set a temperature. And then you come over here, and this is mine, and you put it on the patient. I know that's very simple. I'm going to be giving you some more. It can be a high flow or a low flow, but what this does is it actually reduces dead space and increases oxygenation. And this is really proven to be an overlap and help patients who have serious lung problems from either getting off the ventilator or not getting on the ventilator. It's a tool in between, okay? And I believe that this is here, and it's going to be a mainstay. That's why we're going to be doing this tomorrow and working on it. But this is what we've done. And the last thing I want to say to you is I've shown you all of these things, and would you say that we've covered a lot of stuff this semester? But the most important thing that I believe that you need to know is it's all these little pieces of equipment, but they all fit kind of together, and there's one sheet that helps us know how they all fit together. What sheet is that?
Therapeutic summary sheet.
And that is the most important part. If you understand the therapeutic summary, you're going to have that every single time for every course, every class. You're going to have some kind of therapeutic summary sheet. What are the goals? What are the indications? What are the contraindications? And what are the hazards I got to watch out for? You do that, and we continue to practice this material, you're going to be good to go. I wanted to make sure you knew that as a review, because sometimes you wonder, what did I learn? We learned a lot of formulas too, our alveolar air. We learned the AA ratio, AA gradient. We learned the PF ratio. We learned the CaO2, total O2 content. We learned the CVO2. We learned the Ca minus VO2, looking at how the heart is. We talked about all the different hypoxias. And we also talked about high flow and low flow devices and FiO2s. And at this moment, I am drawing a blank if there was really any other equations except for how to use the peak flow diagram at this moment. And the equipment, total equipment flow formula. Just a brief overview. Please make sure as you're practicing, this stuff is being left out for you to walk through and look at everything. But next Thursday, we're going to be doing the small volume nebulizer. And what I'd hope to do is that we get to the point where when you're going to have a new piece of equipment added to your tool bag, you're going to practice, then record yourself doing the whole treatment. That's going to be part of the checkoff. And then we will have that final day that, yep, this is the day you have to be ready, and then we'll do the actual checkoff at that time. Okay? Does anybody have any questions?
No.
Okay, great. Thank you.